नमस्सभाभ्यः सभापतिभ्यश्च वै नमो नमः। वस्तुतः अहं संस्कृतभाषामाध्यमेनैव अयं व्याख्यानं दत्तुम् इच्छामि, किन्तु दुर्भाग्यवशात् यथा अहं मैकाले वर्यस्य मानसपुत्रः अस्मि, तत्कारणात् मम संस्कृतज्ञानम् न्यूनमपि अस्ति. So I will have my talk in English because the previous speaker talked about the Mleccha Bhasha not even coming one word while he is in India. I'll have to give the sorry face. I'll have to speak in the Mleccha Bhasha. So please bear with me on that. Incidentally, in the IKS center of our institute also, we work on Prajna Paramita Grantha. One of my colleagues, Dr. Nirmalya Guha, has worked on that, the Prajna Paramita Grantha. He has taken it from the Chinese manuscript in that case. So, I am basically trained in Western chemistry. So, my interest has been to look at what has been the chemistry in ancient India. And in ancient India, in the context, it's not just chemistry, it's metallurgy, material science, all put together. So we will just have a Garudavalokanam of this topic through these outline. Starting from the Vedic pronunciation, Hiranyam chame, Ayash chame, Sisam chame, Trapush chame, Shamam chame, Loham chame, where for the very first time we come across explicit mention of 6 different metals. It is very important to distinguish from the history of science point of view, because many times, many civilizations have confused alloys for metals. Mishra Dhatu and Dhatu have always been confused. For instance, bronze and brass. In that context, having pronounced 6 different metals exclusively is not a very trivial information. It has got its own intellectual merit. Then if you look at gold, all civilization, as well as Indian civilization, has dabbled with gold as a first metal to have been processed. So Indian civilization is also not an exception. We find gold in its different synonyms in various instances, starting from Rig Veda. I'll not bother you to give explanation for each. This is just to give a survey where all we find the mention of gold. It's not exhaustive, wherever I could lay my hands on. So, things like Pipilika gold. Even, I think this was the only gold, India was the only country which recognized this Pipilika gold, unbeknownst to the rest of the world during that time. We find a mention of it in Mahabharata. We find gold in its various form in the Ramayana. Next to gold, the Pipilika gold is, suppose you have the river veins and suppose you have the mud deposits next to it, the ant hills, when they start building up, in there they go to the ground or below the ground, and when they are constructing their ant hill, they invariably also dig out the gold. So they are very, very small nodule forms of gold. I forgot to put the picture, but they are pure gold which can be just melted and made into any ornament. So that is called Pipilika, ant gold. It will be varies from like a bundi of a laddu and mega structure, but like it starts with a bundi size of it. Next to gold is the copper, because Western historians have divided history of human civilization as Stone Age, then Copper Age, Bronze Age, and then Iron Age. But in the Krishna Yajurveda we saw the copper, iron, everything is mentioned together, which means either that European anthropological history is not relevant to India, or our Vedic compositions were composed later, which is in fact not true. So this is also serious debate for our historians and anthropologists to have, that when Krishna Yajurveda pronounces the 6 metals, simultaneously, this chronology of Copper Age, Bronze Age, Iron Age does not actually fit in our culture's past. We have had long interaction with copper. This statue that you see here, it's a colossal 8 feet statue excavated from a place called Sultanganj in Bihar by Cunningham, Alexander Cunningham. But unfortunately, we are not in possession of this. This is resting in the Birmingham Museum. Copper is a very reactive metal. Very easily it gets corroded, but this rustless copper, we all talk of rustless iron, but rustless copper is also equally important. Then varieties of alloys of copper, Mishra Dhatu of copper, where you mix copper and tin. Trapu is the Vedic word for tin. And again, it's a matter of unfortunate that today the word trapu in Hindi is not used. They used ranga for tin, or in most of the places they use just the word tin itself. I mean, we are torchbearers of a civilization where we have enormous words. But unfortunately, in these contexts, when we see, we appear to be stricken with poverty of words. For instance, the tin is referred to as tin of English, or at best ranga, but the word trapu has left our literature, our vocabulary. So copper mixed with tin will give you bronze, and right from the Harappan age, even now, if you go to a place called Swamimalai near Tanjavur, you still find the Chola bronzes being made in the same Madhu Uchchishthana Vidhi that was described in Manasara or other Shilpa Shastra text. The other important metal is zinc. Now this is where I, as a Macaulay student, find very difficult because language deceives me. When did we first discover zinc? This is a question that is not well settled. As per the mainstream historians of science, who are not scientists, they are historians, it's from 12th or 13th century. But the ore of zinc is called kharpara, which also appears as khapara in some texts. That we find it even in Arthashastra or even texts, Ayurvedic texts like Charaka Samhita. But whether that is clearly zinc or not, we need linguists, especially Sanskrit scholars, to decipher it. But all said and done, the mainstream narration is what I am presenting to you. For the first time, India was the only country which recognized or which purified zinc in its 100% purity form. It is called Yashada, and the terminology is also very important or interesting. Yasham dadati iti Yashada, but why Yashada? Because it is resembling like silver. As the pure zinc shines like silver, and hence Yashada, and that Yashada due to Apabhramsha becomes Jashada, and Jashada becomes Jasta, which is what is currently used in Hindi and many North Indian places for the zinc. Zinc is from even modern point of view, zinc is a difficult metal because its melting point and evaporation temperature are very close. So the moment it melts, it has a tendency to evaporate if the heat is not stopped. So it cannot be processed in an open furnace, it has to be a closed furnace. That was indigenous invention by the ancient Indians using something called as a Vrintaka Musha. I forgot to put that picture perhaps. But they had manufactured zinc in thousands of tons. And luckily or unluckily for us, it is a British metallurgist who has given the certificate that Indians produced tons of zinc. So now it is everybody believes that. Had any Indian told that we produce tons of zinc, it would have been ghar ki murgi, as they say it in Hindi. So with that certification by a Britisher, now we can proudly thump our chest and say we were the first country to produce pure zinc and export it to the world in thousands of tons. Now again, it's a matter of big research. Today, zinc is used as a galvanizing metal. That's every construction that we have. We have metal reinforcement where iron rods are used. If iron rods are coated with zinc, the rusting gets delayed. That is a current usage of zinc. But 1,000 years back, what was the world using zinc for? To have thousands of tons of zinc getting produced is a bigger question mark and an open area of research which we all need to do. Now zinc, when you mix it with, now the beauty is even a Britisher has given a certificate, and if you look at Chinese text as early as the 6th century, and this is given by Needham, again a British scholar who has brought out several volumes of Science and Technology of China. The Chinese texts claim, what I have shown in the Chinese text here, it claims that they have learned the process of making zinc from India. They claim it, but our government textbooks do not seem to reflect this information. And the dating is also important here. This is 6th century AD. The Chinese text is emphatically claiming they have learned this process from India, but the mainstream historians of science still feel it is a 12th century, 13th century kind of invention. The reason is Europe started distillation at that point of time. So this is done by the process of distillation. So they felt, okay, this distillation must happen in India also in 12th or 13th century. That is the point of history over there. Now if you mix this copper with zinc, you get brass, pittala. There are two types of pittala. One is called accidental pittala and one is called the incidental pittala. Accidental pittala is wherever you have copper ore, that is Makshika, Vimala and Chapala, these are copper ores. You also find zinc ores together. So when you normally process the copper ore, the zinc ore also gets processed, and when you smelt copper, the zinc accidentally gets mixed. But by modern metallurgy, studying phase diagram, we know that in such accidental brass, the percentage of zinc cannot be more than 12 to 13%. And in the incidental brass, where you intentionally mix pure zinc and pure copper, there are archaeological excavations where 40% of zinc is also detected. Even now, as we are sitting, if you go to a place in Bidar, in Karnataka, of course now it is dominated by Muslims, but Bidar is a place where historically high amount of zinc, it is called Bidari work today, a GI tagged product. It is containing zinc as much as 50 to 60% along with copper. So this art of making pure zinc and making high zinc brass has been in India for a very long time. So, and instances of pittala we get again from very ancient periods. Say for instance, in the Atharva Veda. Why I am highlighting this is, this cannot be accidental brass. This has to be intentional brass, which again calls for when did we purify zinc. It is related with that. Because again, if you take Atharva Veda or you come forward to Katyayana Shrauta Sutra, we find several instances of pittala. And interestingly, pittala has got several paryayavachi also. One of them is Riti, Ritika, Arakuta and Suvarnaka Krita. And this has led several translators to mistranslate Suvarnaka Krita as gold instead of brass. And here again I wish to make a point here of alchemy. The Sanskrit verse is not coming into my mind, but the English translation of it goes like this. You roast copper ore with zinc, you get gold. So this is normally given as a hammer to say we were looking at that alchemy, turning everything into gold. But actually speaking, this is the line describing the process of getting brass. And brass, one of the name is Varnaka Krita because it again shines like a gold. And that has led to a lot of confusion by people who have translated it in a wrong manner. And very interestingly, the Shastrakaras here, when they talk of making alloys, they say that these individual dhatus are attaining amaratva. Copper is more reactive in its copper form, but when it is converted into an alloy like brass or a bronze, the reactivity kind of decreases. Its shelf life increases. So it is kind of attaining immortality or amaratva. That is a poetic language with which the Shastrakaras also use for making the alloys. Of course, iron, very known story to all of us, how the rustless iron was not an accidental form in the Delhi iron pillar. I mean, I have shown at least instances of Dhar, this Kodachadri, Kolur Mukambika temple, and this is from the Konark Sun temple where this is lying exposed to the weather, sun and the rain for God alone knows how many years, and still it has not rusted. which surely shows, be it north, south, east or west, the art of manufacturing rustless iron has been in our culture for a very long time. And the Damascus sword, made out of wood's steel, coming from the Tamil word urukku, is again a very internationally acclaimed technological marvel of our country. Besides metals, in terms of instruments, we still use them in the lab, the distillation apparatus. Many people say that this is a gift of the Mughals, but this is indeed, it is there in the Rasarnava text, Rasaratna Samuchaya text. And today also, a photograph is from a place called Kannauj, where it is called the perfume capital of the country, where as described in the ancient text, the apparatus are still used in the same way. And this to me is, as a student of chemistry, is really marvelous, because for the very first time in the world we see the documentation of what we call the flame test. Avartamane kanake pita tare sita prabha shulve neela nibha tikshne krishna varna sureshwari pangejwala kapotabha nage malli dhumaka ityadi. This is the first ever documentation of the flame test which is carried out in the entire world today, where the high school student checks the presence of certain metals by introducing them to the Bunsen burner. Now I'll come to the last part, where the research part, this was a survey part, the introductory remark about mineral acid. I'll just take 5 minutes and I'll close that. Just to give you a background, mineral acids have been like what are called sulfuric acid, nitric acid. Amla is a traditional term, and by amla, our text we always mean the organic sources, that is coming from lemon or pomegranate or tamarind. And it was a belief that Indians did not know mineral acid, and that is also certified by P.C. Ray, although he leaves the benefit of doubt in that. But I wanted to look into the text and see what happens. So I will skip all these details. This is a historical account and the use of acids, the way these are the organic sources of the acids that comes. The definitions of it, I will skip it. In this text, Rasarnava, again the dating of this text is very, very controversial. We have the dates all the way from 300 BC till 1100 AD. There is such a big gap in the dating. That controversy is a separate topic of a separate lecture can be given on that. I'll skip. In this text, interestingly, what we find is a recipe to make something called a mineral acid. Because as from chemistry point of view, if I were to decode it and reproduce it, this has to be mineral acid. So getting inspired from that, these are the substances that are mentioned, which are all inorganic substances. So we took that point, and controversy on the dating, I will skip it. One thing about the Rasarnava, P.C. Ray is of the opinion that it is from 8th century to 9th century, and the author is unknown. But there are instances where we can see that the author is somebody called Shambhu, and the date is again still not settled. I will skip all these things. There is a similar text called Rasarnava Kalpa, again date is not known, where there is a chapter dedicated to what is called as Vishodaka. This is a recipe to make the Vishodaka and what are its properties, which is again containing of only inorganic substances. So what we did, we took those things and we tried to reproduce them as they are being mentioned in this text. This is, for instance, from Arthashastra, where it just says, Jati hingulakena pushpakasisena va gomutra bhavitena digdhena agrahastena samsprishtam suvarnam shveti bhavet. Shveti bhavati. This is actually a test for checking the purity of gold, as mentioned in Arthashastra. So my interest was not to check the purity of gold, but the first half of it, either Jati hingulaka or pushpakasisa, if we mix it in gomutra, then what is happening is that the mineral acid is getting formed. So this is very simple experiment we did. Pushpakasisa is nothing but ferrous sulfate. That if you add it in the gomutra, whose pH is in fact alkaline pH 7.4, the moment you just add this, the pH drops to 3.6, which is only possible if mineral acid is getting formed. That is getting formed in situ there. Similarly, in Sushruta Samhita also we looked at one such text. We repeated it. We saw that the pH drops down to acidic pH of 3.8 and it is stable also. Last time when I presented it, there was a Rasa Shastri in the audience who said that the urine of a calf, young cow, will always be acidic. But then very recently we tested that out. We tested it from the Desi cow, we tested it with the Jersey cow. The urine of the calf is also around the alkaline pH only. So I mean the manuscript is still getting ready. We'll be communicating it soon. So the conclusion that we learned from this is that the mineral acid is indeed, knowledge of mineral acid is there with the ancient Indians. They had used it because otherwise the chemistry that they were discussing to process the metals would not have been possible without the mineral acid. Because organic acids will have a pH not as low as the mineral acids. So from that point of view, we tried to show that this knowledge is indeed there in our ancients. Last closing remark. The other utility, because people may say, fine, these are all good, you had all these things in the past, what is the relevance today? This I am not going into the details of the Ayurvedic, or this is from a Siddha research, where mercury drug was used. Siddha medicine, you also have a campus of Siddha here nearby. The speciality of Siddha medicine is that all the available metals are used as medicines. There is nothing like a toxic metal. But if WHO limit is applied to them, everything will be toxic. Now, the philosophy of Siddha is they convert the metal from its toxic metal form to a aushadhi form, which is completely not toxic. It's therapeutically kind of active. So today we are struggling with a global pandemic called antimicrobial resistance. And mind you, before the discovery of penicillin, the world did not know any antibiotic. And the only drug that they were administering for syphilis or any kind of infection is directly consume pure mercury. After that, whether the person died of syphilis or of mercury, we do not know. But this was a practice rampant until the Second World War, worldwide. Not in India though. But the moment penicillin was discovered, everything shifted to antibiotics, and now since 80 years, we have seen what is the side effect of antibiotics. So today, can we use these herbometallic drugs as an alternate panacea to deal with AMR? I'm sure the chairman of this session, a cardiologist himself, will be able to understand the gravity of the situation that the AMR poses. So using our ancient Vedic wisdom, where we have proven that the metals are not toxic, rather they are converted into a therapeutic agent, why can't this be taken up as, done in a very serious way? I'm not saying just directly give it, but adopting all the protocols, why can't this be posed as an alternative for the antibiotics? So with that, this is a quote inspired from Anna Ramasubramaniam that he often shows. So in his way, it's good to repeat that quote here. Break the mold of the past, but keep safe its gains and its spirit, or else thou hast no future. With those words, I once again thank the Vice Chancellor, Professor Rani Garu, to have given me this opportunity to share a few thoughts of mine. Thank you very much.